Up to this point, we've been designing just half of the scoop. This is advisable with any symmetric part, but especially a complex one like this. Now it's time to start working on the other half. I'll use the mirror feature to mirror the solid body of the bowl and the two surface bodies in the handle across the right plane. If I turn off Edge Display and look at the end of the handle, notice the presence of an unattractive nub. Now this has been caused by a number of things, but the main culprit is that the two profiles of direction 1 and the boundary surface intersected at a right angle. This makes it difficult for the boundary surface to make a nice rounded end. This kind of situation is very common when creating handles with rounded ends. The following is an equally common fix. First, I'll create a ruled surface skirt around the end of the handle. I'll hide the top surface body just created as well as its mirrored body. I'll then select the two edges of the bottom handle surface around the end and initiate the ruled surface feature. I'll use the tapered to vector option, using the top plane as the vector. It doesn't matter how big the surface is, but enter about a ½ inch or so, using a taper of 5 degrees. Toggle the direction and watch the preview to make sure that the surface goes down and out from the selected edges. I'll click OK to complete the ruled surface. Once the ruled surface is created, I'll hide the bottom handle surface bodies. Remember, there are two of them because they were mirrored but not knit together. The next step is to remove the unsightly portion of the surface. I'll show the top surfaces hidden earlier to make the nub visible. I'll sketch a line on the top plane just past where the unwanted ridge on the handle blends back into the part and looks smooth again. Now I initiate the trim feature and trim away the unsightly bump and leave the part of the ruled surface around the gap. The ruled surface is acting as construction geometry for the new smoother patch. To fill in the patch, I use the Fill Surface feature. I'll select all 4 edges around the gap and assign curvature to all edges. I'll disable Optimize Surface. Be aware that you may get a warning message that displays on the screen when doing this that says a tangency constraint might not be taken into account because it is not consistent. This is because the edge of the ruled surface is not exactly tangent to the trimmed edge of the top handle surface. The fill surface in this situation does the best it can, but you should be aware that it's not perfect. In this case, it is good enough because we'll be eliminating the ruled surface, and that edge will be a non-tangent edge anyway. You will need to use your own judgment as far as what good enough means. Deviation analysis is a great way to quantify the error. Deviation analysis is discussed further in the detergent bottle example later in the course.